In this video, I will help you get started with practice with mole calculations 1. I'm going to focus on number 3. Number 1 and number 2 are straight mass to moles calculations, so going from grams to moles. Number 3 actually requires a mass to moles calculation and then a follow-up moles to atoms calculation. So number 3, the first part of number 3, is the same process that you'll use for number 1 and number 2. So let me bring this up on my screen a little bit bigger, and we'll walk through the calculations. So the problem is talking about a very, very small sample of tungsten, which is atomic number 74, symbol is W, and we want to convert this really tiny mass of tungsten, which would represent the tiny filament up here in the light bulb. We want to figure out how many atoms that is. Okay, so to do that, we always use moles first, because we know a mole of anything has Avogadro's number of particles in that substance. So if I can get the quantity to moles, I can then use Avogadro's number to calculate how many atoms. I should note, in a typical chemistry lab or investigation, this is not a step that you would ever take. We'll see that the number of atoms is really, really, really big, and in most cases, we just want to look at moles and mole ratios in ordinary chem labs. But this at least shows us just how big that number is. So if we look at our information, this is the mass of tungsten that would be in the filament here. And our first step is to calculate moles. So I'm going to go ahead and note my starting value, 0.0176 grams of tungsten. And I first need to convert to moles, and that hint is given here. So setting up my conversion factor, I know that I want grams of tungsten to cancel. I want to end up in moles of tungsten. To figure out that ratio, I need to go to the periodic table. Tungsten is atomic number 74. It's got a molar mass of 183.84 grams. So 183.84 grams is equivalent to 1 mole if we're dealing with tungsten. Now, I will say at this point, I could go ahead and do this calculation and figure out how many moles I have. Grams would cancel, and I would end up in moles. However, I need to go one more step to figure out how many atoms are in this sample. So I recommend, when this is the case, just stringing together conversion factors so that you can do the calculations all in one step, and then you round at the last step. So what I'm looking for here is I want moles of tungsten to cancel, and I want to end up in atoms of tungsten. So here's where we need to use Avogadro's number. 1 mole of anything contains Avogadro's number of particles. The particles here that we're dealing with are atoms. So I need to multiply by Avogadro's number, and we are going to use a value of 6.022 times 10 to the 23rd power for Avogadro's number. That is how many atoms would be in 1 mole of tungsten. At that point, moles would cancel, and I will end up in atoms, which is what I want. So when you set up a string of conversion factors, remember you multiply across the top. So everything across the top multiplies together, and then you divide by anything in the denominator in the bottom of the fraction. So I'm going to type in to my calculator. I've got times 1 here. I'm not going to worry about that. I want to type in 0.0176 times Avogadro's number, 6.022 times 10 to the 23rd, and then I'm going to divide by the molar mass, and that should give me the atom amount. Now, I want to show you specifically how I would recommend typing that into your calculator. So let me switch over to my camera. So again, what I'm calculating is the starting value in grams, 0.0176, times Avogadro's number. Now, my recommendation for Avogadro's number is to use the EE function. EE means enter exponent for scientific notation. So the way I'm going to type in Avogadro's number is 6.022, and EE is a second function. So I'm going to go second EE, and on the screen it just shows a capital E. This means times 10 to the, and the is what you'll enter in as the exponent. So this is 6.022 times 10 to the 23rd. The advantage of using that key is that the calculator will treat this all as one number. If you go through the trouble of multiplying times 10 to some power, sometimes those two parts can be kind of separated and you can run into some problems. So the other thing I needed to do is divide by the value in the denominator, which was the molar mass of tungsten. I go ahead and hit equals, and it gives me my answer in scientific notation. Notice this is times 10 to the 19th power. Now my starting value had 3 significant digits, so I want to round this to 5.7, and then I'm going to round up 7. So 5.77 times 10 to the 19th power. .77 times 10 to the 19th power, and that is atoms of tungsten. Okay, now it's a really big number, right? We've talked about the fact that even in a small sample, there are many particles in that sample. So this is a tiny little sample of tungsten, and we have this many atoms in it. Just to impress upon you how big that is, if I were to write this in expanded notation, I would need to move the decimal here 19 spaces to the right. So I would go 5, 7, 7. That's 2 spaces, and I would need to add 17 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Add some commas in. And that's just how many atoms you would have even in a small sample. And that's why typically if we're just comparing amounts of atoms, we don't care to convert all the way to the atom amount. We stick with moles. Hopefully that helps you get started. On the next page of the problems, these are empirical formula problems. So all we need to do on this page is go from grams to moles for each of the elements involved in the compound. And then once you have those mole values, you want to compare them. You're looking for whole number ratios that would reflect the formula of the particular compound you're looking at. So if it's a 2-to-1 ratio, that tells you that the formula should have a subscript 2 and a subscript 1, which we just leave off. So those are first requiring you to calculate moles and then compare the mole ratio to get the formula. I hope that helps. Let me know if you have any questions. Thanks.